So our second finalist is Roger Guiel from the Department of Mechanical Engineering. His major professor is Dr. Konstantin Chicanel. Roger's presentation title is Power Harvesting Using Shape Memory Alloys.
Inefficiencies in power generation are something that most people don't really think about, but as an engineer, I can never forget them. Nuclear energy, a source of 20% of the United States' power, is a process that is 90% efficient, which is exceptionally good. Your car, on the other hand, is only around 40% efficient. This means that 60% of the energy generated in your car is lost due to inefficiencies in heat, vibration, and other outlets. Now, you can harvest this wasted heat energy, but the process is large and the technology is cumbersome. The vibrational, on the other hand, is something worth exploring. My research focuses on harvesting wasted vibrational energy and turning it into usable electricity. I work with a novel class of smart materials called magnetic shape memory alloys. This material will actually remember its shape in the presence of a magnet. In other words, if I take the material and I compress it between my fingers, if I put it near a magnet, it will actually cause it to elongate back to its original length. This is due to tiny crystals inside the material that try to elongate and align themselves with the applied magnetic field. You can think of these crystals as little dominoes that when you put a magnet nearby, they actually jump up. Because the crystals are the exact same shape as those dominoes, with one side much smaller than the other side, when they do jump up, this causes the material to elongate. Now, the material can then be compressed back down, shortening the material, and then toppling those crystals back over. Now, to what I do. I take this material and I wedge it in between two magnets, causing all those dominoes to jump up into the upright position. I then compress it back down, toppling them over. Once I do eventually let go of the material, everything springs back up because it's still in between those magnets. Now, according to Faraday's law of induction, if you have a changing magnetic field, you can actually use that to generate power. During this process of the crystals going down and up and back and forth, it actually causes a fluctuation in the magnetic field. And so I put a coil around the material, which then causes this system to generate electricity. With the system set up this way, I can turn any rapid small movement into usable electricity. Think about how much a bridge wobbles when a car drives over it, or how much a wooden floor shakes when you walk on it. This material can be used to harvest any amount of wasted vibrational energy. Last summer, we created a self-powered road sensor that utilized 4 pieces of this magnetic shape memory alloy. It turned the energy of cars passing over it into usable electricity to power small electronic components inside the sensor. Now, with growing energy demands across the globe, discussions like this, including power harvesting and energy efficiency, are going to become much more commonplace in every facet of education. It's up to us to continue this discussion and continue to improve ways of harvesting wasted energy. Thank you.